Arijit. So today I'm coming with another new project of Zomato restaurant clustering and sentiment analysis, and this is a totally unsupervised ML model. Okay, let's start with the project. So first, the project summary. The project centers around Zomato, a prominent online food delivery platform. It involves two key datasets, one for restaurant information and the other for user reviews. The initial phase of this project involves rigorous data cleaning and pre-processing to ensure the data suitability for comprehensive analysis. Subsequently, we conduct exploratory data analysis on both datasets, providing insights into the dataset's compose and features. Okay, moving forward, this is the GitHub link. You can directly go to the project by clicking this link. Okay, coming to the project's statement. Project title is Zomato Restaurant Clustering and Sentiment Analysis. So the main objective of this project is to conduct EDN, clustering and sentiment analysis on two datasets related to Zomato, a popular restaurant discovery and food delivery platforms. The analysis aims to gain insights into restaurant clustering and user sentiments towards different restaurants listed on Zomato. So this is the first dataset and this is the second dataset. Let's begin the project. So these are the libraries which I will be using over here. So I'm mounting my Google Drive. After that, I'm storing the two dataset in two different variable named metadf and reviewdf. This is the first 5 views of metadf, and this is the first 5 views of reviewdf. Okay, these are the shapes of metadf and reviewdf. You can see over here. Metadata consists of 105 rows and 6 columns, and reviewdf consists of 10,000 rows and 7 columns. Okay, these are the informations of both of the variable or both of the data set. And moving forward, now I will be checking the duplicate values if present any or not. So you can see in duplicate values in restaurant reviews data, that is 36 duplicate values are present. Now seeing for the missing values, and this is the visualization of missing values for metadf, and this is the visualization of missing values for reviewdf. Okay, now understanding the variables. These are the variables of both the dataset, and this is the description of metadf, and this is the description of reviewdf. These are the variable description you can see over here. Now checking for the unique values, if any. So you can see the unique values of both of the dataset. Now the data wrangling part. Firstly, I have changed the cost function from object to integer. Then I have dropped null values if present any in reviewdf. After that, I have dropped reviewdf rating, which has likes, and after that I have changed the rating to float, and these are the rest of the manipulation which I have did over the dataset. So now you can see the reviewdf head over here, and these I did for extracting time, years and months. So what all manipulation have I done? That is, in restaurant data, I have converted the data type of the cost features from objects to integers for improved consistency and numerical analysis. Review data, since there were very few missing values in the review data, I opted to remove them to maintain data integrity. Additionally, I enhanced the dataset by converting the rating features from object to float. For precise analysis, I enriched the dataset by extracting valuable information such as followers and reviews from the metadata. To provide a more comprehensive analysis, I also extracted the time, year, month and hour of when each review was created, enabling more in-depth temporal insights. Okay. After all the manipulation and data wrangling, now let's come to the data visualization part. Chart 1. Okay, I have made top 10 affordable restaurant by cost and top 10 costly restaurant by cost. You can see the chart over here. Now what are the insights I've got? Among all the restaurants, college at Hyatt Hyderabad, something Gachibowli is the priciest. Okay, will it gain any insights? Yes, we can recommend this restaurant to customers who are looking for upscale dining experiences with higher priced menu items. Coming with the chart to visualization, so top 10 cuisines by restaurant counts. You can see the top 10 cuisines, North India and Chinese are the top, one of the top 10. Okay, insights, that is North Indian restaurants are prevalent primarily due to significant numbers of patrons originating from the North Indian regions. Did I gain any insights? And that is, as evident from the data, there is a high demand of North Indian and Chinese cuisines. Therefore, it makes strategic sense to focus on targeting these customer segments. Coming to the chart 3, top 10 reviews by maximum followers. These are the top 10 reviews by maximum followers. So we have discovered that Satvinder Singh and Eat With Me are the top 2 reviewers with the largest number of followers. If we require advertising services, these individuals could be potential choices. Okay, now chart number 4, top 10 restaurant collections we will be seeing. Okay, what are the insights found from the chart? Great buffets is mostly used at restaurant. Now, will it get any insight? That is, insights aid in identifying the most popular restaurant tags, enabling businesses to offer promotions and discounts to those who with lower popularity. Now, coming to chart number 5, top 10 reviewers by average rating. These are the top 10 reviewers by average rating. So, for instances, reviewers like Eat With Me and Food Porn have consistently given an average rating of 5. This could imply either frequent visits to top-notch restaurants or a tendency to rate all restaurants with a perfect score. Okay, will it gain an insight? And that is, such insights given in charts are valuable for sentiment analysis and provide essential context for restaurant reviews. Okay, now coming to chart number 6, that is review counts by month. Okay, Feb to August, there is very active period for a restaurant except June. Will this get any insight? During these time frames, Zomato may consider increasing their delivery personnel and offering promotional codes to boost activity in less active periods. Okay, now coming to chart number 5. For this, I have made a word cloud, and where we will be combining the top 30 reviews in a single text, and these are the top 30 reviews in a single text. Tasty, nice, and ordered quick, ambience, food good, and many more. Beer, overall yummy. That's it. Okay, coming to chart number 8, that is top 5 reviewers by review count. So we have determined that Ankita, Parijat and Kiran are the top 3 reviewers based on their activity. We can consider engaging Ankita, Parijat and Kiran as reviewers for multiple restaurants. Given their prolific reviewing activity, their preferences align with the type of restaurants they may favor. Now coming to chart number 9, that is top 10 cuisines by average cost. Okay, I've identified the modern Indian sushi and BBQ cuisines rank among the most expensive options in terms of cost. Will this give an insight? That is, yes, restaurants owners or operators can leverage this information to make strategic decisions, such as pricing these cuisines competitively and tailoring marketing efforts to attract customers seeking premium dining experiences. By catering to the demand of these higher cost cuisines, the businesses can potentially increase its revenue and profitability. Now I'm making a heat map over here. So what are the insights? That is, assess the correlation among all the numeric variable. Did I get an insight? That is, the data set contains limited data for certain years, such as 2018 and 2019, with particular sparse data for the year 2016 and 2017. Consequently, the correlation analysis may not yield significant insights. Okay, now moving forward, hypothesis testing. Okay, I will not be elaborating this hypothesis testing. If you are very much curious, you can visit my project and go through the hypothesis testing which I have done over here. Okay, let's move forward now. Feature engineering and data preprocessing, handling the missing values. So these are all the things which I did. So let's directly go to the manipulation which I have did. What all missing values imputation techniques have you used and why did you use those techniques? I filled in missing collection values with the mean value of 3, which includes barbecue and grill, happy hours and cakes and events. I replaced NaN values in the number of followers with 0. Handling outliers. Since this data set is very less, so I will not be doing any outlier detection. Now, categorical encoding. These are the categorical encoding which I did over here. Clustering dummy and all. So what are categorical encoding techniques have you used and why did you use those techniques? I performed one hot encoding on the cuisine column while leaving the average rating and cost variable unchanged since they are numeric variables. Textual data preprocessing. It's mandatory for textual data preprocessing, Okay. Expand contraction. So these are the manipulation which I did over here. Sentimental DF. I'm making it. Now after that I'm like lower casing the alphabets or sentences, and after that I'm removing the punctuations. Now I'm removing the URLs and remove words and digits contains digits. Now I will be removing stop words and removing white spaces. Removing stop words, making a function named delete stop words. Okay. Now I will be doing tokenization on review column or dataset, you can say. After that I will be doing text normalization. Okay. Which text normalization techniques have you used and why? I have done limmatization techniques as it is good way to reduce words which are used in different ways can be converted into its root words. Okay. Part of speech tagging. Text vectorization. Now I will be doing text vectorization by calling TF-IDF, that is term frequency inverse document frequency, since it can be more effective in certain situations compared to count vectorization. Now feature manipulation and selections. Now I will be doing feature manipulation and selections. You can see cluster dummy.head over here. Okay. Sentiment here, which is previous most processing output of video. For rating above average, we take as 1 and below average 0. You can see here I did the manipulation calling the lambda function over here. Now data transformation. Do you think that your data needs to be transformed? If yes, which transformation have you used and specified? These are all the transformation which I did over here. I applied a log transformation to the cost column to address its positive skewness. Okay. Data scaling. Now coming to data scaling, I used standard scaler and the numerical column variable names. I have stored cost, total cuisine counts and average rating columns. I have scaled I have stored the standard scaler in scalar variable, and after that I fit the cluster dummy from numerical columns, scale df and all. Okay. Which method have you used to scale your data and why? In this case, I apply the standard scaler which is appropriate for data that exhibits a normal distribution. Dimensionality reduction. Do you think the dimensionality reduction is indeed needed? Explain why. Indeed, with a higher return of features, there is a risk of overfitting the model, which can result in poor generalization. Therefore, feature reduction becomes crucial to improve model performance. Okay. This is the scaled DF column. Now I will be using PCA to reduce the dimension and training the model. So I have implemented PCA, that is principal component analysis. Now you can see the variance versus number of components, cumulative explained variance. Okay, which dimensional reduction techniques have you used and why? PCA principal component analysis is widely used dimensionality reduction method. In this particular case, PCA was employed to reduce the dimensionality to 3 based on the characteristics of the elbow curve. This is the elbow curve, you can see over here. Okay. Data splitting. Now I will be splitting the data. Splitting of data to train and test to splitting ratio wisely. I have created this during vectorization. Okay. What splitting ratio have you used and why? Given the dataset size of approximately 10,000 records, I decided to split the data into an 80-20 ratio for training and testing respectively. Okay. Handling imbalanced dataset. Okay. It appears that the dataset is well suited for analysis since there is only a minor class imbalance. Now implementing the ML model. Firstly, I will be implementing k-means. So you can see the elbow curve over here, and I can see the bend from 4 to 5. Okay, let's see. Moving forward, this is the silhouette analysis. You can see the clusters over here. It is selecting 8 clusters, and going by here you can see the 9 clusters over here. Okay, moving forward, visualizing the clusters and data points in each cluster. Now these are the 6 clusters you can see, and this is the representation for each of the clusters over here. Okay, joining the clusters. Now I will be joining the clusters over here. Back to normal form log during transformation. Okay, these are the column names over here right now. Now clustering result, clustering dummy in copy. So these are all the transformations and everything which I did over here. You can go through this. Okay, I opted for the k-mean clusters methods in this case because the data doesn't have hierarchical categories, making k-mean suitable. Additionally, I determined that k is equals to 6 is the optimal choice as it yields the highest silhouette score. Okay, cross validation and hyperparameter tuning. Which hyperparameter optimization techniques have you used and why? I employed a combination of the elbow curve and silhouette score analysis to determine the optimal number of clusters. K in K means clusterings. The elbow curve helps identify the point at which within clustered sum of squares WCSS starts to level out. Indicating the appropriate number of clusters, the silhouette score measures how well separated the clusters are with higher value, suggesting better cluster separation by using these techniques. I aim to find the K value that optimizes cluster separations and quality. Have you seen any improvement? Note down the improvement with updates evaluation matrix score chart. That is, yes, the key improvement observed is the selection of an appropriate value for K. By analyzing the silhouette scores for different values of K, I identified that K is equal to 6, yielding the highest silhouette score, which suggests better cluster separation. This improvement in the evaluation metric silhouette score indicates that the clustering results with K is equal to 6 are expected to be more well defined and distinct compared to other values of K, leading to better cluster quality. Okay. Now coming to model number 2, that is LDA, latent direct allocation. So this is the silhouette score graph. You can see LDA, implementing LDA with selecting 4 components. This is the visualization. Because I'm recording over here, that's why I cannot show you the exact visualization. So when you will be visiting my projects, you can hover over here and see the visualization. Like if you hover over here, you can see the estimated term frequency within the scale topics compared with overall term frequency. Okay. These are for PC1 model, PC3 model, PC4 model, PC2 model, and minimum. Okay, let's continue. Review sentiment prediction reviews. Okay, these are the review sentiments predictions, and I'm converting it to list and copying it. Now transforming X in LDA and saving it in topic results, and you can see these are the results. Okay, now again forming word cloud over here, creating a list of strings for each topic, creating a word cloud for each topic. These are the word cloud for each topic. Okay. Now sentiment in review sentiment prediction. These are all the predictions rating. You can see over here. Now implementing supervised learning. I will be seeing the ROC, AOC score, effort score, accuracy score, and defining the functions over here. You can see over here. Logistic and XGBoost algorithm. I will be using logistic regression and XGBoost algorithm right now. Now plotting, that is, this is the ROC AUC curve. You can see this nearly for logistic regression is 0.91 and for XGB classifier is 0.93. So XGB classifier is like we can see it is more accurate. Means the model is really working good. Okay, which hyperparameter optimization techniques have you used and why? I employed research even though it can be time consuming because it is a powerful optimization techniques that typically leads to the best outcomes. Have you seen an improvement? Note down the improvement with updates, evaluation metrics, score chart. The method has produced highly favorable results indicating its effectiveness. Okay. Explain each evaluation metrics indicating towards business and businesses impact of the ML model used. The ROC scores quantifies the probability of accuracy classifying new observations, making it of significant business importance. These was the last model. Let's see. Okay, now coming to the conclusion. In this project, we successfully applied various data pre-processing techniques to enhance the quality of our textual dataset, making it suitable for machine learning. Optimize clustering. Through k-means clusterings, we optimize the number of clusters and improve the Silhouette score, indicating better cluster separation with k is equals to 6 as the optimal value. Topic modeling. We employed latent direct allocation to reveal key topic within reviews. The topic analysis provided valuable insights into the most discussed themes. Okay, model performance. Coming to model performance, supervised models including logistic regression and edge boost saw remarkable improvements in key evaluation metrics after hyperparametric tuning. Improved precisions, achieved high precisions essentials for accurate position sentiment predictions in sentiment analysis task, which is crucial for businesses interpreting customer segments and sentiments. Enhanced recall. Demonstrated high recall, ensuring that positive instances are captured effectively are valuable features in applications that should not miss positive cases. Balanced F1 score. Attained a balanced F1 score, offering a trade-off between precision and recall, which is beneficial for applications demanding a balance between accuracy and coverage. Okay. ROC AUC significance. The ROC AUC score improved post tuning, highlighting the model's ability to distinguish between positive and negative instances, pivotal for classification accuracy. Model deployment. Okay. Discussed the importance of setting the best performance model in a deployment format, setting the stage for real world applications. Impact on business. Emphasized that our project has the potential to empower business with data-driven insights, enhancing decision-making capabilities. And data transformation. From text preprocessing to model selection, our project showcases the transformative power of data science, converting raw data into actionable knowledge. Okay. This was all about the project. Thank you.